Okay, we'd like to get the afternoon session started. So we have our keynote speaker now, Bary Silverstein, and then the posters are 2 o'clock back where you just had lunch, and so we just keep you going back and forth all day. But I want to introduce Bary Silverstein first. Now, Bary has been a longtime friend of CEIS and several of us for many years here in Rochester, and now that he's back again, he has a new role here at the university. But Bary is the director of the University of Rochester's Center for Extended Reality, and he has a distinguished leadership career in optics that spans research, product development, and commercialization in imaging and display technologies. So he's a Rochester optics alum, and he spent 28 years at Eastman Kodak working on systems ranging from space-based optics to 3D digital cinema. And he later led hardware R&D at IMAX, where he helped to develop or led the development of the company's next generation laser projection system. And then he moved to the West Coast and served at Meta Reality Labs as senior director and CTO of optics and display research. So his work there focused on optical display and photonic technologies for AR and VR headsets. And in the past year, Bary has returned to Rochester and accepted the role as director of the Center for Extended Reality. And he's working on building a transdisciplinary effort that links optics, AI, computing, neuroscience, education, and the humanities to advance extended realities in ways that are both technologically significant and broadly beneficial to society. So Bary's talk today is Beyond Smart Display Glasses, Creating a Path to Comfort, Context, and Depth in Spatial Computing. So Bary.
Wow, is that what I was supposed to talk about? Uh-oh. So, okay, it's after lunch. We typically get a little groggy, so I'm going to try to make this as lively as possible, and I think you'll be very interested. So, the Center for Extended Reality is targeted to address what I call the future of human-computer connection. And the university is very, very wise to be moving in this direction because things are starting to integrate. A transdisciplinary center should be able to pull the university together to address this. Now, the center is working around the concept that AR, in conjunction with contextual AI, will be this future of human-computer connection. But let me explain what that is. So when you combine these things together, you'll have a powerful means of working with computing that is different than today. But let's go back a little bit and think about how these technologies come together. I like to play a little game of, do you remember when? So depending upon your age, and I won't point any fingers, but I remember when, a TV and a radio and a music player and a phone and a camera and a wallet were all separate things, right? So raise your hand if you remember that. Okay, come on, guys. Okay, I should say, raise your hand if you do not remember that. Okay, yeah. So if you're old and don't remember it, it's one reason. If you're young and don't remember it, it's another reason. So, but of course, today we have this all-in-one device, and this is what I see happening again. History repeats itself, and so we have one device. The phone does pretty much all of these things. And we're starting to see a migration of other technologies come into play as well that serve additional functions. So if you move to the watch, you're also getting, in addition to those particular functions, you're also getting measurements of body dynamics. So the phone measures your steps and your gait, if you didn't know, and of course tracks your location. But now you add a watch, and the watch is now measuring your heart and your oxygen level, if patent law allows, if you didn't know that one. But we're moving even beyond that into smart glasses. So this is the Meta Ray-Ban display, which I worked on, and an EMG band. So if you're not familiar with this product, because you can't get your hands on them because they're in limited supply. It's got a small display in it, roughly 20 degrees by 20 degrees. That is intermittent use. We call it snacking, display snacking. And so this provides you information in your eyes, not just audibly. So, and these glasses have cameras, and they have audio, and they connect to AI, and can display, so you can ask a question, and you can get an answer back, either auditorially or visually. And this is profound. And the EMG wristband now enables you to control this in innocuous ways, right? So basically, I could have my hand behind my back and do a click or a scroll, right? So you don't have to pull anything out or touch or tap anything. You just use your hand in a very natural way. So this is moving in a particular direction. Now, this has just begun, but there's more stuff. There's more stuff to move towards this direction of AR and contextual AI that's necessary. The first thing that you might say you want is a wider field of view, okay? Because a small display is not very immersive. It's not really AR. It's just information. But of course, as you go up in field of view, you also go up in power usage, and it's much more challenging. This is Meta's Orion prototype, which I also worked on. And this has a 70-degree field of view. So imagine 70 degrees is about like that. Okay, so give you an idea, an IMAX screen is about 54 degrees in the center of an auditorium. So this is a big screen, and this can immerse you in digital content. It has the same wristband. This also has interesting and important features of eye tracking, and eye tracking is critically important if you're doing contextually aware AI. Because how do you determine what people are doing, and what they're interested in, what they're paying attention to? This is done through eye tracking. There's also depth sensing. So it measures the world as your camera also can do, but including it into a pair of glasses is challenging. But depth is critically important to know where objects are in the real world. What this is missing is a few things. So we got to fix a few things in order to make this vision come true. The first thing is getting perception right. So these glasses offer essentially a 2D screen. They don't offer a 3D screen. So Orion has two displays, not just one like the Meta Ray-Bans. So it has stereo, but it doesn't have true depth. And in VR, if you're familiar, in VR you can sort of get away with this because you only have one screen. The entire world is one screen, and that entire screen is at one image plane. So typically at arm's length. Okay, so they put the screen here, and they fake 3D. So this is pseudo 3D by just moving the displays like this so that your eyes verge. This is called verging. Okay, and you could do that for a while in VR and be comfortable. You could do that for a little while in a movie theater and get 3D like that. But if you do too much of it, you get sick. So anybody here get VR sickness? We got a couple, right? Yeah. Not so good. Perception mismatch, okay? That's not a good thing for a product, okay? So some people could accept it for a while, but in AR, it just doesn't work. So you can't fake depth in AR because you need to overlay your images onto a real object. If I have an object here, and I think I have a slide on this, well, okay, I'll get to that slide in a minute. So you can't fake that, and this is critically important. So in typical display world, we have most things are like brightness and color in a 2D system, but in a 3D system where you have a 210-degree field of view, and you typically have problems with perception that are more pronounced. And these can cause sickness or just disruption to the continuity of the information. So going back to this topic of depth, if you have an object near to you, okay, your eyes are going to change their lens shape, and your eyes are going to move in, and it's called verging, right? So I'm looking at this microphone, my eyes are moving in, my lenses change shape, and that's what my brain is expecting. okay? Now, if I'm looking at a distance, my eyes move straight out, the lenses change curvature again, okay? And that's what my brain is expecting. Now, what the display systems of today are in AR is a fixed plane. So you can put a screen up, and again, they're going to choose right about here because this is an intermediary plane. So, but if I try to overlay an object on something that is nearer to me, okay, this is going to be out of focus. There's going to be a mismatch. Or if I try to overlay something in a distance, again, there's going to be a mismatch. You can't actually overlay because you can't move that image to the right plane. This is a fundamental flaw. So for the most part, until we fix that, you don't have an AR system. It's not augmented reality. It is a display system on your head, which is different. It's information on your head. And understanding that is critically important, but also appreciating what you could do with a contextual AI is important. So now how do you fix some of these things? Well, and this process is called accommodation, what our eyes do, this movement of our lenses. So the first way that you can fix this is to actually move this digital image plane, okay? And there are technologies out there that have been trying to do this. There's, for example, liquid crystal lenses. So you flick a switch and you get a lens that changes its depth. This is okay because it's flat and it's kind of light, but it does take power. And you'll notice that there's this funny grading structure on it. It's not very socially acceptable, so I'm not a big fan. But there's a second path here. This is an Oxford Optical Labs approach, which is a liquid lens. So basically it is doing what your eye does in the lens shape here. And that's really very interesting. The problem is incorporating that into a nice lightweight pair of glasses is a challenge. Okay, so you could actually do this, and you could do prescription correction like this, and that will be coming. But doing this when you're combining it with a display pair of glasses is a challenge. But you can expect to start to see these kind of technologies roll in place. Now, when we talk about contextual AI, I also shared about the eye tracking before. Right now, the AR glasses don't have eye tracking in them because it adds too much weight and it takes up too much power. And when it comes to be that they put these into a pair of glasses, it's going to be intermittent use because the power is too hungry. What you see there are arrays of LEDs that are around the glasses, frames that are shined onto the lens of your eye, and then a camera is used to process the motion of your eye to get gaze direction. While this is effective, it is not incredibly accurate, and it's incredibly power hungry. So imagine processing real time the images. Okay, you have both latency and you have the overhead of compute. It isn't necessarily just the LEDs that you're powering up. It is also the camera and the processing. So this is a problem, and this is something that we're going to work on at the University of Rochester to fix. Now, observing the real world, there are already cameras on these glasses. Great, but what you'll note is that these cameras take a single image. What am I looking at? Click, okay? And then you'll get a description in your ear of what you're looking at. That's interesting now, kind of a fun party trick, but that doesn't deliver always on contextual AI, right? You're not getting much context, you're getting intermittent context. Now, the industry will move towards event capture that'll be kind of automated, so something happened, and therefore you take a capture and you process it. But of course, if you process it with these cameras that are high megapixel, that's great, you get more information, but managing that information is a problem. And if you try to think of doing this real time, what you'd like, to have continuous context, it becomes incredibly cumbersome, very, very high power, and cameras will also get hot. Okay, so between the processing and the cameras, you really need to do something different. And where I think this will head is very similar to what is talked about in the display world. You'll notice that this picture is made up of what's called a point cloud, okay, where the image in the center is heavy in data, and the points dissipate as you move. And so this is actually the way our bodies work, our eyes work. The retina has roughly a 3-degree high resolution zone, and the rest of it falls off very rapidly. And what do? We scan the world, okay? So our bodies are in fact walking scanners. So we move our eyes, we move our head. So if we move our eyes first, if you need more movement, you move your head, and you need more movement than that, you move your body. So first of all, with glasses on, you'll take advantage of our bodies, which will walk around. But in terms of the eye movement, you're not going to have a camera lens that moves, but you can have imaging that foveates, that does a point cloud relative to what your gaze is. Okay, so you're not capturing all of that information and processing all of that information. And what do? We actually move around, we scan the world, and we kind of build up a mental model. And this is point cloud mapping, okay? And so what I expect for contextual systems is to build the models of the world through this point cloud mapping. So you'll reduce bandwidth, you'll reduce, you may have the pixels there, but you may not use them, okay? You're going to use them more sparsely relative to your eye position. Now, what you'd like is more sensing. So now, who knows Geordi here? Okay. So if you haven't watched Star Trek or Star Trek Next Generation, you have to, because pretty much everything that I'm talking about here is built into the show and has been since the 1950s. So Geordi's wearing a visor. The visor has the ability to scan the world and look at the world in ways that the human is not able to process. So spectrometers and thermal measurements and other types of things probably that he adds into his system to enhance him because he was blind. The more sensing that we have is more context that we can feed to an AI. So what would I add? What would I add next? Well, it turns out you don't have to look very far for some of the things that are going to be added. Facial tracking. So these are two efforts. There's a company, and this lower one here was done at Cornell. By some researchers at Cornell that are using two different types of sensing to measure the face. Why is this important for contextual AI? Well, emotions. In general, people express emotions through their facial expressions. You and I learn about our friends and our partners and our family and how they react to things by body language, which you can already get by gait and some other things. But the face is the big one. Emotions are tracked in the face. So when you can track faces, you can do two things. One is you can make an accurate avatar, which is what the target was here. But the other thing is, how did people react to a particular set of context, right? So then learn, right? So you learn about your friends. They got pissed off when they got that message from someone, okay? Or they were happy when they got their grade back on an exam. So this is something that's important in order for an AI assistant, a contextually aware assistant, to use. Moving up a step further, you can move to EEG. And these are hats, if you can look at the picture behind it, these are hats with EEG systems in them, okay? And what can you do with an EEG system? So in addition to the emotion tracking that you're getting from the facial tracking, now you can get some idea of brain signals. And the brain signals, by the shape of the signals and also the location that's occurring in the brain, can give some level of inference on what the person is thinking, okay? In addition, what they're processing, I should say. Not necessarily, thinking might be a little strong, because you can't understand what they're thinking, but you can understand what are they processing? What area of the brain are they processing? And this would be additional information. But I like to think of this a little bit further down the line, because what they've already been showing in research is that you can type. You can train your brain. You can train your brain to do things like type a letter at a time, okay? Not overly sophisticated, but if you want to create a direct link with the computer, you don't necessarily have to put a neural link like Elon Musk is suggesting, because people generally don't like surgery, brain surgery for consumer electronics that has a 5-year lifetime. Not a great idea, right? But you can start to pick up some of these signals. And use them for helping to align more inference with the AI. So I call this a second brain, okay? So you're walking around with these cameras, you're walking around with audio sensing, okay? You're scanning the world, it's scanning the world, it's got sensors that are higher bandwidth than you. Did you know that you only process around kilobytes per second? Okay? You're actually really bad. You guys are all really bad. You're really bad at viewing the world, okay? So I expect these systems to have more bandwidth than us. So the things that you missed or you thought you saw, right? You might be able to have our second brain. I usually have it on my right side. You could put it on your left side. But the second brain will be able to help process the world for you, okay, in an additional way. The question is, how will we use it, right? So how will we use this second brain? And I have this grand vision that this processing will be done. So imagine imagine 1 billion people wearing these glasses at a time, with all of these sensors processing the world at a time: audio, visual, maybe some other sensing, some oxygen sensing, and body motion. All these things coming together, being fed into this AI system. That's a lot of data, right? And that's a lot of processing. You see all the servers going up around the world just to be able to rewrite our emails, okay, and make a few pictures. There's something that's going to have to change here. So there's another project that we'll be discussing at the university, which is photonic integrated quantum computing. So I won't go into that today, but in my dream, the University of Rochester delivers the next integrated chip through photonics, and then supports this system. So, but what will you do with your second brain? That is the question, right? So what you don't want to do is have it take over for you, okay? So if any of you are following the articles, like students not learning, they're just getting information, right? I can just ask ChatGPT to answer this math problem or write this essay. Well, guess what? You're being dumbified, okay? And being dumbified might feel good at that moment, but in the long haul, it's really terrible for society, okay? And it will be terrible for each of us. So this is not the answer. So when I talk about an assistant, I do mean an assistant. Helping you be a better human is different than doing everything that humans can do, maybe even better, okay? And right now that's in our control, but pay attention. It's rapidly changing where it may not be in our control, okay? And I will also warn you that the big players that are in this field, the big tech companies that are in this field, look at this as cash, okay? So they're going to try and tie you into their systems so that they can increase their revenue regardless of the implications to society. So that's something to pay attention to. But we can use it, okay? So there are two halves of this story. The left half is barren. Left? Yes, it's left to you. Is barren, where humans don't have a purpose anymore, which really makes me nervous for the future generation. And there's the right hand where we are enhanced, where we can do more with our capabilities, where we become partners with the computing system to help us, enable us to be better. And the center is targeted to make us green, okay? I want to put us over on the green mark. So this is not just about hardware. The Center for Extended Reality is not just about hardware. It is to work on this entire ecosystem so that we build a better world for humanity. That's lofty, and usually when I have this discussion, I feel like a science fiction movie where the scientist is standing up. Watch out, world! We have this AI is going to come and destroy us, and if you don't pay attention, humanity is going to die, right? So you ever watch that movie? I've watched that probably 10 different movies. Yeah. So, but the fact is, we do. We have to pay attention. It's here. We have to pay attention and make sure what we're building is also ethical, moral, and good for human individuals and society, in addition to just the technology. So, how do you do this? So the center is doing this by breaking it down into 4 pillars. The 4 pillars start with hardware. I discussed a lot of hardware already, and I'll discuss a little bit more because that is our starting place at the University of Rochester, and this is a technology talk. But the second part is human interface. The third one's applications, and then social impact. So in hardware, as I mentioned, it starts with display. There's audio that has to combine perceptually accurate with display. There's biosensing, there's haptics, there's compute, there's communications, there's battery and packaging. All of this stuff needs to come together in a seamless, comfortable way that you can wear on your head. It'll migrate there slowly, little by little, just like the smartphone did. Pieces came together and progressed. The human interface is a little more complicated. I break this down into 3 sections. The first one is fashion, okay? We don't want to look like dorks when we're wearing this hardware, okay? And it has to be comfortable so you don't stick it in your drawer after the first week of wearing it. And it has to be usable, like you better be able to use it outside. Is it bright enough, right? So your phone has trouble outside. Can you use it on the beach and does it melt your head when you wear it? Perception matching is a very important thing. We already talked about perception matching. This ties heavily with the neuroscience group at the university and CVS, the Center for Visual Sciences. And then there's this thing called the contextual AI, okay, manager. We can change the name. If our AI folks want us to change the name, we'll change the name. But basically, this is a different user interface. So it is absorbing all that information from around the world and providing the information back to you that is relevant, useful, not annoying, and not dangerous. I like to usually say, when I speak, it's really important not to have an Excel spreadsheet go up, pop in front of your eyes when you're crossing the street, okay? Kind of obvious, right? It isn't necessarily so obvious, right? It's not necessarily so obvious that folks have thought this through. Right now, we sometimes walk in the trees, okay? But this is in our control to go like this. When it's here, it is not in our control anymore. You're not doing this to cross the street, okay? So this needs to be managed. Safety, but also just annoyance. If any of you remember Clippy from Microsoft that everybody hated in the corner, okay? Everyone hated Clippy. Can you imagine Clippy coming into your screen and saying, hey, you got a message, right? No, that's not going to be great when you're having a conversation one-on-one. So it's important to do this, getting this right. Now, then we talk about applications, and this is mostly medicine and education. I'm going to talk about that and social impact later. So how do you do all this? Well, turns out that the University of Rochester and the university ecosystem is incredibly well suited for this because we have all the pieces that go into this puzzle. So we have the optics department, and we have AI and data sciences, and we have audio. We have all the hardware pieces in the engineering area. Okay, not all of them. There's some gaps, but you partner for the gaps. But we also have application areas, medicine and education, right around the corner. We have the humanities that want to use tools like this. We also have people who think about social impact, philosophers, social scientists, psychologists, and political science. If you're going to do politics, political science, you should have something good to argue over for policy. This is well worth it. So let's talk a bit about the hardware, okay? And how am I doing on time? Okay. We'll talk a little bit about the hardware. I'm going to start with optics because that's where I'm housed. We need to build capacity through adjustments of the current display path. So I want to walk through the display path. Actually, I'm going to run through the display path because this is not an optics crowd. So I want to let you know what's coming. So the glasses are made up of a stack. The display glasses are made up of a stack which has a whole bunch of optics in it. And we call this the impossible sandwich because it has so many functions that are built into it. It's really a challenge to make some of these, okay? And adding all these pieces together makes the glasses heavy and uncomfortable. But that was also true of this. You saw how eventually things got shrunk down and you were able to put it in your pocket, right? We have supercomputers in our pocket with high resolution displays and batteries, et cetera. This is what's going to happen over time. We'll simplify this. But the approach that's taken today is using a diffractive waveguide, and this is a structure that contains light inside of a substrate of typically glass with a light engine that feeds it and then outputs to the eye repeatedly, so that wherever you move your eye, you get a view of the image. Now, this is basically nano structuring glass to do this. It's very sophisticated, somewhat expensive, and very inefficient. Okay, so typically less than 1% of the light goes into the eye. Okay, so this is an area that's going to need to be fixed. It's also limited in how big a screen you can have by the index refraction of the material. So the material that's chosen limits it. This has led to one of the breakthroughs, which is a silicon carbide substrate, which has a very high index of refraction. And this material was turned transmissive, so you can see the transmissive version over here. By purifying it, the version on the left is used for high-power electronics, high-speed, high-frequency electronics. So there's a big industry that's been working in this space. Turning this into an optical substrate actually is very interesting, and this also leads to the quantum computing path that I think that we can do. So doing this enables you to get the 70-degree field of view. That was what was in that Orion display. Eventually, though, currently the illumination, the light path is done with LEDs and liquid crystal on silicon imager chips. This is pretty old technology. It's the same stuff that many desktop projectors had, and it just shrunk down. But it's moving to what's called micro LED technology, and micro LED technology is simply that, taking basic LEDs of red, green, and blue and shrinking them down to small sizes. Turns out when you do that, there's a couple problems. One is that their efficiency drops, and the second problem is trying to get 5-micron pixels of color, especially all three colors, to not have defects in them, so that you get a nice uniform image is a big challenge. But this is what billions and billions has been spent to do. But I believe it's going to move to lasers ultimately, and so does most of the industry, because of one reason, or two reasons. First of all, if you want to get the best, most efficient light into your eye, you need to have the most transmission. You need to see the real world at the same time as you're seeing your display. That means that you need to differentiate the light from the display from the real world, so that you can maximize both, right? You can't maximize both. So the idea is to use very narrow laser beams, narrow band beams that are polarized, which is kind of excluding almost all the other light. Use that for your display, okay? So that you can create filters that reflect the light from your laser display into your eyes while transmitting the rest of the world light. This is a maximum signal-to-noise kind of ratio thing. And this will fix a lot of problems, but it is not easy. There's things that need to be solved. But there's maybe even a bigger reason is fundamental efficiency. So if you look on this chart in the circle here, you'll compare the étendue efficiency, which means the light that you can actually use from the sources. If you look at right here, multi-mode lasers, 28%. Okay, micro LED, 1.5%. Okay, so this is usable light. So, and I usually say if you're not getting function out of something, you're creating heat. So it's battery power. You're going to be using extra battery power. You're going to be creating heat, which is not a very good thing to wear on your head. So eventually, to get to the maximum level of performance, you're going to switch to lasers. But this is a slow process, and this is something that the University of Rochester will be leading as well. I'm going to pass on these because I'm going to run out of time. I want to talk more about fashion. So fashion is an interesting thing. So we are used to wearing glasses, and this is what the market is aiming for. And that's because we don't want to look strange. And what this does is it forces the technology into a box where it's hard to make all the functions that you'd like to have. Remember I talked about accommodation and you'd like efficiency and high brightness. Trying to do that in a pair of glasses that looks like a pair of glasses, that's lightweight like a pair of glasses, is one of the big challenges. And so there's sacrifices to be made in this product line. So one of the things that I wonder about is how far can we deviate from this if the value is high enough? And I use this as an example. So when Apple came out with their iPod, they used to have people dancing on the screen with a wire. And the wire was white, and they called it out as a feature, as a fashion thing. Okay, this is cool. You dance with your wire, right? You got music. It was considered cool and acceptable, and people really liked it because the product was so great. Of course, until they decided that they didn't need wires anymore, and then all of a sudden they said they created something where you had cigarette butts hanging from your ears. Okay, and all of a sudden cigarette butts from your ears. Now I remember before that people had the headsets that were black that they were trying to hide, and if you walked around the supermarket wearing a headset like this, okay, and you were talking on them, people will look at you funny, okay, like you're a weirdo, okay, but when Apple did it, oh man, let's make it vivid white and hanging from 2 ears, and it was okay. So we are flexible as people, okay, is the point, if the value is high enough. So I wonder whether or not we will be flexible enough to move away from the glasses form factor into something else. Remember, Jordy had a visor on, okay. That was okay in the theoretical future, but it wouldn't be okay now. So, but that if we could do that, that enables us to engineer things that might be a little bit better. Now, I want to point out that glasses are, in fact, glasses after all. They're very unique, okay? There are 406 million different variations of product for glasses, okay? In terms of the lenses, not the frames, this is just the lenses. In other words, to get to the accuracy that everyone needs with the curvature being right, the fixing astigmatism, which is angularly oriented, all of this represents a huge customization challenge that consumer eyewear or that consumer electronics is not used to doing, okay? And this is a huge barrier because when Meta does a prescription pair of lenses for you, in your glasses for that display system, if the prescription's wrong, you throw away the whole thing. Okay? How many of you had to have glasses replaced within a year or even immediately? Okay? All of us, right? So certainly within 2 years. You're going to throw away these things? This is a big challenge, and this is a big industrial issue. So there are new technologies that are being brought to bear. You can't just add a lens into your existing prescription, your existing pair of glasses. Why not? Because it's too heavy. So this is the heaviest part of the glasses is in fact the lens, and you've already got a display on there with a system in it that's eating up almost all the weight allocation that you can manage on your nose. Okay. Now, if you add another lens, you're overweight, and all of a sudden you lose the comfort. So this is a big challenge. So to the right there, you will see a new technology of inkjet printing 3D lenses on top of a display system. So this is where I think it may be going, okay? This way you don't need a separate substrate, you just print on top of the existing lens display. However, at this point, it's irreversible, so you're still throwing away. So we need to get to the point where you can peel it off and start over. Something that the University of Rochester might be interested in working on. But RX integration is not simple. And you start with your eye care professional, and then usually they have an lenses and frames that you select right next door, and you go through that, and then it goes through a custom order, and eventually a couple weeks later you get it back and you try it on and you say this doesn't work, and then they ship it back, etc. Sometimes it does work, but this is complicated, and this is very atypical relative to a consumer electronics product. So this makes this wearable very challenging from a business standpoint. So now I want to go back to this fashion thing. So you heard the overall vision of trying to create contextually aware AI glasses. But we can actually get started on this journey a little sooner to get advanced on some of the technology pieces and some of the applications before that really happens in full steam. And by doing that, by narrowing down what you prioritize, you can move things forward. So we are starting to work on a pair of goggles, a little more like that than glasses, that will deliver the 70-degree form factor with a high resolution, with high comfort that's easy to make, with eye tracking accommodation and RX correction, okay, for many purposes, certainly research, but also for a customer that I think is very much in need. And this is what I call the USA Display Project. And this would be in partnership with local Rochester companies that are able to make all of the pieces in town, which is unique for technologies where mostly in Asia. And so one of the things that you may not know is that there's only one company in the United States that can make a display anymore, and it is OLED Works, which is a spin out from some Kodak employees that developed OLED to begin with. Okay, and so they're one of the companies that we're partnering with to make this pair of glasses or this pair of eyewear. Now, who would be the customer for this first? Well, the military would be first, okay? They cannot get a single USA-made display for all of their needs at all today, okay? Which is a fundamental problem. The good part of that is there's opportunity here to get funding, okay? So, and everything revolves around getting funding. So we will be going after funding by demonstrating a prototype of this display system, which I will believe will be much better than any of the glasses that are offered, because it's not glasses. It's wearable display. Soldiers don't care about fashion. Actually, they do. They have to look mean, okay? So we can make them look mean, okay? So that's not necessarily good for a bar, but it's very good for a soldier. But if you take that concept and now move it into other application spaces, and this is the genie behind the thing. So the military applications, defense applications are useful, but not where my heart is. The other applications are. So first responders, yes, firemen, policemen, et cetera, and soldiers, of course. But medicine. So two things, or three things, which are actually here on the picture. So the University of Rochester Medical System is already using training in VR, okay? It is not perceptually correct training, however, okay? We can fix that. Treatment, they are also doing treatment. So the surgeons have a HoloLens, which is a terrible imaging device, by the way, perceptually incorrect. We can improve this and have surgeons with an overlay of MRI and CT scans and other information that's available to them without having to look over at a screen. Okay, be overlaid right onto the body, because remember I said depth matters, so, and perception matters. And our folks at CVS have figured out some of the perception, actually the neuroscience guys have figured out some perception things that have not been addressed yet in any of the headsets. So we're ahead in some of these concepts to be able to improve people's actual perception. And then there's treatment and tracking. If you could put a pair of goggles like these on your patient who is being sent home for treatment of, let's call it Parkinson's or epilepsy, and you want to see how their everyday life is changing, you no longer have to interview them and get qualitative data that patients are particularly not good at. Remember the kilobytes I said? We're not particularly good note takers, okay? So now you can get actually measurable data, quantitative data on how well treatments are working. And as it moves closer and closer to all day, it becomes trending. So heart trending, right, is already on my wrist. So this trending will move along. Interestingly enough, education is nearly identical. So training, what's the difference between a welder and a soldier? Pay rate for one, but you know, the precision might matter a little differently, but the skills are very similar, right? So you're doing something with your hand coordinated to manipulate things. Tutoring. So instead of having AI be an information dump onto you to solve your problems, it can help you like a teacher, okay? See what you're doing, see where you're struggling. Why do you keep getting stuck on that word? How can I assist you with that word? Not to tell you the whole story that you're supposed to be reading. Tracking and trending. So same thing as with the patient. Where are you getting stuck? Okay, where might you need assistance? What are your strengths? What are your weaknesses? Quantitatively assessed. And then there's humanities, which we should never ignore. There's the necessity to move creation into the digital and real realm simultaneously. Shared experiences, being able to experience things without hopping on a plane, okay, and having them perceptually accurate so you feel like you're being there in a shared environment with others. Avatars are going to be important. Remember, you're going to need the face tracking for the avatars. And then authentic collaboration at a distance. Once you have these perceptually accurate avatars, you'll be able to have meetings in the digital or combined spaces that make you feel like you're actually with a human being, and it is different, right? I do a lot of VC calls with many of you, some of you in the room, and just being here feels different. It is more engaging. Social impact, this is a sticky one, okay? So CXR is, we need to address privacy, we need to address trust with these systems. We need to address open standards so that we're not locked into particular companies' ecosystem. And if they have a slanted AI that they're delivering stuff to you, you won't be manipulated as much, or at least you have control over such things. But what is good for humanity? How do we know what part of this is good for us? The only way to do that is to run run experiments, okay? And a university environment is good for running experiments. We need to test out what is best for humanity and don't just make assumptions. The next part is we need to share our voices, okay? So what we want our future to look like needs to be shared. So we are currently being delivered technology that we accept because of the perceived value to us, not fully being aware of the value or what is being taken away from us. So how many of us use Google Maps or Apple Maps? Everybody, right? Oh, come on, you guys didn't raise your hand. I know you do, right? So they're tracking you. They know you guys are sitting next to each other, and they know your contacts, okay? So when one of you searches on sailboats, and you're sitting next to the other two, they make the inference that maybe you're talking about sailboats. And all of a sudden, you get an ad for a sailboat, okay? Now, that seems innocuous enough, so you signed it off, right? Actually, you said, I want my map now. Yes, 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 right? We all did that, okay? But you don't realize what you signed away. Now take this a step further. Now you have your heart monitor. Now it's my health. I want to share that with my doctor. Uh-oh, who owns that data? Apple's getting this. Apple's not HIPAA compliant. They can share that with whomever they want, maybe in their agreement, maybe not. Depends on the company, right? And and it depends on the company and the moment, which CEO is in place. They just changed the agreement on you, right? This is so now I told you heart, okay? Now it's facial expressions. They know you're sad. Uh-oh, do I really want Meta knowing I'm sad? I'm not so sure I want Meta knowing I'm sad. Do I care about Apple? Well, they seem better. Oh, but Tim Cook is leaving. Maybe the next guy's different, okay? So it's going to matter. Uh-oh, EEG, yikes, right? So we're treading into some really tough turf here. They're going to do it from economics. They're going to give it to you for pseudo-free, but they're going to extract. And their AI is going to feed you stuff and train your mind to give them money, right? That's what the supermarkets do. That's what all the commercial things do. That's their business model. That's okay if there's guardrails. If we don't speak up and create guardrails, then we're screwed, okay? They will take advantage of us. So our voices matter, and now is the time to get involved in voices. We will be involved in policy research and policy informing for policymakers to hopefully make better decisions. Oh, I got ahead of myself. Inform policy, right? We don't make policy at the university, but the political science majors that are going into political science to be politicians are going to be trained here. They should know about this stuff and know who to talk to, right? And understand some of these topics. So informed by the philosophy department that's dealing with ethics and morals, informed by the social sciences that deal with social issues, and informed by psychologists that are dealing with individual mental health issues. This is critically important. So I shared today a vision of XR and contextual AI in the 4 pillars. And I want to talk a little bit about the circle, and then I'm done. So first, we need to understand this topic. Thank you for all coming today to understand about what this vision looks like. It's cool, but it's also scary. This also drives research. What do we want this to be? How do we make this happen? Okay, so there's hardware research, there's application research, there is social implication research. If we decide what is most important to us, we can concentrate on those research areas. We can deliver solutions. Those solutions can be fed to industry and policymakers, okay? Industry is about money, economic opportunity for the University of Rochester graduates, researchers, and the community. That feeds back into our education system so that we can continue the circle. Thank you.
So we have time for a few questions.
Just wondering if in your social policy direction, you're considering standards. IEEE has a society for social implications of technology and a standardization group that are looking at trying to provide guardrails in a number of different directions of technologies that are being developed.
Yeah, so IEEE is one. There's the XR Association. There's a separate health group. So what I'm looking for are people who could be representative to multiple agencies because we need to work through multiple channels. So the IEEE will be heavily focused on the hardware, not necessarily some of the other aspects of it. Right, so XR Association is heavily addressing the education and a little bit on the medicine side, and then there is a medical group that is addressing some of the medicine areas. But yes, so if anybody wants to volunteer to work on and be representatives to some of these communities to bring it back into the university's ecosystem, I'm looking for help. Thank you.
Hello, yeah. So I had a question regarding the applications of the AR glasses. I also work a little bit with the AR glasses and also with like low vision users. So I wanted to ask if you are doing any sort of like accessibility work, and if you are, what sort of features would that include for, let's say, people with visual impairments?
Yeah, so to date, most of this stuff has happened because, most of the accessibility work has happened because it just so happens to be good for some of these things. It'd be nice to be a little more intentional. And we will be partnering hopefully partnering with NTID for hearing impairment. For visual impairment as well, there are things that we can do, and we'd be very thrilled to have folks that want to work in this domain. This is something that can enhance people's lives greatly. I have been in touch with people who've reached out about this topic. Usually that they have a significant other who could use some enhancement. But contextual AI is essentially built for this, right? So the tools will be there, and it's a matter of connecting them up with the right companies or startups that want to provide the service.
Anything else? Yeah.
I don't hear you talking about. Oh, I don't hear you talking about the mentioning sounds and the audition. Wonder whether that's fit into the scope. When you talk about perception, there's in computer science notion of multimodal perception.
Yeah.
And then I also see GL Professor Duan there is doing a lot of work with sound. I just wonder what's your view on that side?
So sound is critically important. In fact, if it doesn't match reality, and the folks in this room know, if it doesn't match reality, it is also a breaker for perception. So the reason that I don't concentrate on it as much is because it is further along than the display. So it is not what I'd say amazingly great at this point, but it is currently not the barrier to our perception and display. Leads the problem space. Okay, but the minute it becomes the next thing in line, right? It has to be addressed. All this needs to be done simultaneously, and I'll even say to some level, haptics is also in there. So audio is definitely included, and audio is part of CXR, right? So what I'd like to say is CXR is not a department. We have all the departments. We have audio. We have people working on audio. We have optics. So the idea here is that in your spaces, in your domains, in your expertise, let's target this to make sure that we get the technologies right to match perception. So in my mind, it's all part of the same effort.
Thank you. Wonderful talk. So I have a question actually from the system perspective. there are devices like self-driving cars that can be viewed as an AR device, for example, right? But it's only designed for a specific scenario. There are also devices, for example, developed by Meta or large tech companies. They are developing the generic device to support different kind of scenarios or applications. Now, which kind of systems do you think we should focus on or will be more promising for the next, let's say, 5 or 10 years in terms of the applications and the market and where should we put the focus on about research and development?
Yeah, so it's an interesting parallel. I often quote that we're trying to build a self-driving car on your head. Okay, all of that processing that is being done in a self-driving car needs to be done on your head. Okay, but that and then some. Okay, because it's much more than that. It isn't just staying between the lines and not hitting a car, right? It is processing emotion and all these other aspects. So the answer is all of the above, and nobody knows. Okay, so if I told you, hey, this is the direction that we should absolutely go in, well, 2 years ago, before AI was a big thing, okay, and significant. The glasses, the display was the most important thing at Meta, okay? And then AI hit, and they wiped out most of the display team because AI is the most important thing to part of this, okay? So things change depending upon breakthroughs that happen and customer dynamics, which nobody knows yet. So we're all making assumptions about what people want to do. Now, you're going to hopefully hear about a project, two projects. One is a newsletter, which is a kind of a top-down education to our community. The other one is bottoms-up. So I want you all to imagine having what I described on your head and ask yourself, what's your day look like? What do you want it to look like? What do you want it to do? Okay? What is most important to you? Okay, and you, and you, and you. Okay? Now, that informs us what might be the highest value things to work on, okay? Do I need to improve eye tracking because that's absolutely critical because I need it for education? Or do I need a wider field of view because I need to have this overlay? Which is more important? Nobody knows yet, but if you tell me what things you want to do, now that you've imagined it, now hopefully that I planted a seed in your head of what this thing is going to look like, you'll start to think about it. It's like, well, if I had this, this is what I would do. And also, by the way, this is what I'm afraid of. I don't want this to happen, okay? Those two things will inform our community on what the most valuable projects are to pursue in terms of research and development at the university.
Yeah, I think the people putting on posters are going to wonder where the audience is. So let's thank Bary again.